All right, thanks, Kirsten. And good morning, everyone. My name is Matt Ashton. I am a systems engineer here at Gigamon. I've been a member of the public sector team here at Gigamon for a little over 4 years now, supporting mostly the Air Force, the Space Force, and Missile Defense Agency. I also have a lot of experience on the civilian side and the channel aspect of things. And, I also serve as the Zero Trust overlay for our team. So I'm definitely happy and to be here today to speak with you all, to talk about how Gigamon helps enable Zero Trust with hybrid network visibility and analytics. It's not just me today. I'm joined by a few esteemed colleagues. I definitely want to point out Jorge Valverde, who's one of our systems engineers, mostly on the civilian side, but he is an overlay when it comes to cloud. Very intelligent man, and I'm glad he has my back on today's call. Midway through, the slides, I don't want to slide you all to death. We'll do the demo. And I know that we're the only vendor who's going to present today. So I know we have 75 minutes of allotted time. My goal is to get you out sooner than that, since it is Friday. So across this presentation, I'm going to cover a few topics. I want to start off by giving more information in terms of who Gigamon is as a company. Also, I want to talk about today's network security challenges that we're seeing across the industry, not just in the public sector, but also in the private realm as well. We're all here for Zero Trust, so we definitely want to recap some of the Zero Trust capabilities and pillars and tenets, but we don't want to be redundant. We know that, it's a long series of different vendors who've presented on this, and so we don't want to, cover the same topics over and over again, but just how we play in the Zero Trust architecture overall. Also, we want to talk about establishing dynamic risk evaluation. I was specifically called out in terms of some of the ATARC materials, and that's a big part of Zero Trust is dynamically evaluating risk and how Gigamon plays a role in that with our visibility solutions. And lastly, I want to talk about a couple of use cases. The 12 Zero Trust scenarios that have been brought up in terms of the ATARC huddle, we want to address those, and we do play a part in each of those scenarios. So we'll quickly skim through those. And also we have our own use case in terms of how Gigamon has actually been deployed in a DoD Zero Trust architecture pilot, which is pretty cool. And yeah, lastly, we'll do a demo more so in terms of hybrid cloud visibility, and Jorge will kind of spearhead that. So here's a marketing slide. Gigamon has been around for a very long time. We consider ourselves, the godfather when it comes to network visibility and analytics. We were founded in 2004. We are the recognized market leader when it comes to network visibility and analytics, especially in the federal government. With I think now our market share has grown to close to 63%, but also in the private realm as well, and enterprise. Top 10 out of 10 largest federal agencies, 84 of the top Fortune 100. So we have a vast array of different customers who use our visibility solutions across a number of different pillars and verticals, pardon me. Also want to call attention to, since I come from the DoD side, some of the use cases and deployments that we're a part of when it comes to the federal government. More specifically, the joint DoD Zero Trust pilot at Dreamport is what I will have a few slides on to kind of dive deeper in terms of how we play a role in providing visibility in that Zero Trust architecture. But anything from planes, ships, data centers, highly secure data centers, we provide visibility into all those different environments. Also, we like to stay on top of our certifications and accreditations so that we remain compliant and that we're with you along the way in terms of having compliant hardware and software solutions. So this is the network, or a resemblance of a network that we typically come across when Gigamon is not involved. And this is very complex with tools all over the place, some to monitor from a networking perspective and the performance of the network, some from the application perspective of inspecting application performance, but also from a security perspective, tools deployed to secure the network, inspect traffic. And when it comes to visibility, and I define visibility as being able to access traffic, being able to glean meaningful insights from that traffic as well, right? So typically in an on-prem data center, to do this, you had to deploy tools all over the place. And for those tools to get some sense of visibility, you would have to deploy multiple instances of those tools in multiple parts of the physical network. And even yet and still, as you continue to scale up, that more and more physical tools and hardware into the network, you're not really still getting a full sense of visibility. It's still a lot of blind spots. And we've seen that with the number of high profile breaches that have gone on in the past few years, right? And, you know, all these companies have major stacks of security and performance tools, yet there's still blind spots where adversaries are able to, you know, take advantage of, move laterally across the network and, you know, access resources, usually without raising some sort of flag. Now, if you compound that with the digital transformation era where, you know, organizations and companies are starting to leverage cloud resources, pay for what you use, on-demand resources, managed services, you're taking resources out of the major data center that you own, and you're taking that into the cloud, where you don't necessarily own that physical hardware and infrastructure. So, you know, you're moving high value assets into a cloud environment, which you don't have full control over. On top of that, with COVID, your workforce is being decentralized. So no longer are all your, you know, high privileged users accessing data while within, you know, headquarters or the main data center. They're working from home, and they're using VPNs and other technologies to access high value resources from either within the data center, on-prem, or in the cloud. So that's all to say that it's a lot going on. And in order to, you know, come up with something a little bit more scalable as we move into the future, we need to take into account the ways that we can deliver more meaningful traffic to tools, allow tools to have a better way of accessing that data, and also being able to provide visibility, once again, access to data wherever your data is, not just in the data center, but if you're going to move data or parts of an application or system into the cloud, the same tools that you have on-prem might not work in the cloud. You know, and there's a ton of other things when it comes to accruing technical debt and licensing and so on and so forth and managing. All in all, you need visibility across the entire enterprise wherever your data is, whether that's on-prem, in a virtualized cloud with VMware or Nutanix, that's on-prem, or even in the cloud with public cloud providers like Google, Azure, AWS. And that's what Gigamon really provides as a visibility and analytics fabric. We take on the responsibility of accessing data on behalf of your tools. We will access, in, you know, via taps. We will tap data from the on-prem network via physical taps. And if you have workloads in the cloud or in a virtual on-prem solution, we can tap those workloads as well. So we will take on that responsibility of accessing all the data. And that, when I say data, I mean packets from a layer 2 perspective, from, you know, regardless of where your data is. Secondly, once we can access that data, we can centralize that data into what we call our visibility fabric. We know where all that data is. We can account for that data. And now that we have all that data and we can account for it within our fabric, there's a number of interesting things that we can do to manage that data and make, and, you know, create relevant data streams from that to send to certain tools. Not every tool needs to see every piece of data. They don't need to see every packet. Tools need to see packets a certain type of way. Sometimes they don't need to see the payload. Maybe certain performance monitoring tools only need to see the headers, right? Maybe certain tools like web application firewalls only need to see web traffic. So instead of having your tools kind of drink water out of a fire hose, why don't we, you know, significantly cull that amount of irrelevant traffic and that noise and just send the data that's relevant? So, pardon me. Yeah, this fully fleshed out slide, we're able to tap the traffic, aggregate it into our fabric, and then we can either send relevant data to tools, and we can also transform those packets. So we can dedupe traffic. Since we're collecting and tapping data from multiple places on-prem, in the cloud, everywhere, you're bound to run into duplicate packets. And that can really, you know, shorten your cycles in terms of data retention because you're retaining wasted traffic and duplicate packets. So we can really help optimize the tools, which is the ultimate goal, by only sending those tools, and, you know, many of them have presented today, I mean, over the past couple of months with ATAR, by only sending them the data that they need to see, how they need to see it, right? It really helps out with the tool because a lot of tools, they have those functions as well. Maybe they can dedupe, or maybe they can decrypt, but that's not that tool's main function. And, you know, if you turn on those capabilities for those tools, that takes away meaningful resources and CPU and memory allocation that otherwise could be used to perform their primary functions. So not only are we taking on the responsibility of aggregating traffic from across the enterprise, we're really making sure that whatever data is going to that tool or that system that's processing that data, they only see the data that they need to see, nothing more, nothing less. Lastly, before I move on from this slide, it's important to note it's not just about deduping and packet slicing. There's a number of different GigaSmart features that we can do to transform the packet. Decryption is huge, especially when it comes to zero trust. We can also decrypt traffic. If we're deployed inline, dealing with live production traffic, we can decrypt packets all the way up to TLS 1.3. Even if you're using an out-of-band kind of circumstance where we're tapping the data and just taking mirrored packets and not dealing with live production traffic, we can decrypt packets all the way up to TLS 1.2. So it still really opens up the amount of data that your tools have access to, at least from a complete set. And then we can start to massage that data down to only send the best of the best. And I want to keep in mind, if you all have any questions, please put them in the chat. Jorge, if you could do me a favor and kind of answer some of them, or if there's something that's really relevant to maybe bring up on the presentation, please feel free to cut me off and interject. And, we can keep it somewhat interactive as well, since we're the only vendors presenting today. So moving on with zero trust, we define zero trust is not necessarily an architecture, right? It's not a set list of components, right? Every organization and governing body has a different definition and list of pillars and capabilities in regards to what zero trust really is. However, we do believe that zero trust is a mindset. It's a mindset of never trust and always verify anything that's moving across and throughout your data center, your enterprise. And zero trust has been around for quite some time. We all know this, at least over 10 years in terms of the concept and the original white papers that have been published. But it really just brings together a lot of the long-standing principles that us in cybersecurity and in the IT space all are familiar with, whether it's least privilege, access control, multi-factor authentication, defense in depth, and then some other things that we're aware of but don't always get practiced, like eliminating implicit trust, shifting security focus to data instead of maybe assets, context awareness, leveraging more metadata and context around decisions or activities that are going on in the network to make a more refined decision and accurate decision on what needs to be allowed and what should be denied. Particularly when it comes to ATARC and the DoD, and we've seen this capability model and core pillars of zero trust. We don't map to every single capability. However, as a visibility and analytics solution that we provide, the fact that we can really tap into network traffic, which is a single source of truth, because we're tapping data across the network, so data in motion, we're not just capturing network data, we're capturing endpoint data, we're capturing user data, we're capturing device data, all types of data, because all of that data moves across the network at some point, right? So, across all of these pillars, we may not cover everything, but the fact that we're able to access data from the network and send that in whatever data you want to send to certain tools or systems that need to process that data, we cover a large portion of the field in terms of the different capabilities that ATARC and the DoD define as being required. I just want to reiterate that, we really implement a monitoring plane. So there's the data plane, there's a control plane, but then there's also a monitoring plane, which is great for zero trust, right? Because we're able to tap, and we prefer taps over spans in the physical infrastructure, but we can also take in data from spans. But we can tap any workload in any environment, regardless of where it is. And in doing so, we can also implement solutions, like I've mentioned, like decrypting certain traffic, or even extracting rich contextual metadata from those packets to send to a SIEM or a SOAR tool for further processing or policy decisions, right? And I'll cover a little bit more of that later on. But ultimately, the point of the slide is to show, hey, we tap everywhere. We're able to aggregate that data. We can decrypt, we can extract metadata, we can clean up data by deduping, we can obfuscate traffic or data in payloads by masking certain data. Certain data might be tunneled, and certain tools might have a hard time processing that data because of those encapsulation headers, right? So I don't want to get too technical, but the fact that we can maybe strip encapsulation headers before going to those particular tools really helps open up the set of data that those tools can process. These tools and these different vendors are great at what they do, but sometimes the environment in terms of accessing data is just not up to par in terms of suiting their needs. So we really take on that responsibility of getting that data and making sense of it before sending it to the tools. So not only are the tools receiving the traffic how they want to see it, but the data that they're seeing is coming from originally a complete set of data across the entire infrastructure. Lastly, I want to mention our Fabric Manager. As you continue to deploy and expand our visibility solution, or just visibility in general, network visibility in general, you have multiple nodes in different locations throughout the enterprise, on-prem, in the cloud, and on-prem virtual. So you need some sort of way to manage that entire deployment without having to go to each individual node and make configurations in an ad hoc, siloed way. And that's why Fabric Manager is great. It's our centralized management plane, where you're able to drill in and out of each environment, whether that's on-prem or in the cloud or virtual, and make policy decisions in terms of what traffic is selected, what data of interest do we want to extract, and where do we want to send those packets to. And all of that can be used from one web page, one tab, right? It makes it super easy. We also give you very, very robust widgets and customizable widgets to assess the health of your entire fabric. Your fabric being whatever nodes you have deployed that are interacting with network traffic. And it also is great because it opens up our API set. Our RESTful APIs, which can integrate with a number of different tools, or even custom scripting for any type of automation or orchestration that you would like to take place. Lastly, Fabric Manager is great for RBAC. We talk about zero trust. Access control is important, right? We're dealing with a lot of packets. So, it's important to have Fabric Manager in place, not just to have that single pane of glass management interface, but also to be granular in who has access to what activities and capabilities to certain resources. So a big part of our visibility solution, or a major offering that we have, is our application intelligence suite. So originally, we would identify and select packets that we're seeing coming into our fabric from layer 2 to layer 4. So we can isolate traffic from a particular VLAN and send it to this tool, or we can isolate data coming from this particular source IP, maybe this node that is generating syslog, and send it to that tool. But now with application intelligence, we can make pass drop decisions in terms of what data goes to what destination based on a layer 7 perspective. We can actually perform deep packet inspection on all the packets that we're seeing coming into our fabric. And out of the box, we can identify over 3,000 different applications, services, and protocols. So all of the popular protocols like HTTP, HTTPS, instead of having to denote port 80 and port 443, but also more applications like YouTube, Facebook, or now Meta, Twitter, a lot of social media, high volume, low value traffic that we can just identify as that application, instead of having to use a regex expression or try to remember what port it's coming out of, which is extremely hard to do. So it really allows us to be more granular in not only seeing what applications are coming across your environment, but also being able to determine which of those applications of interest do you want to send to which tools, right? So just to recap, in terms of the visualization portion of our app intelligence, we're able to classify and show you out of the box over 3,000 apps, services, and protocols. And these are across a number of different families. I mentioned social media, but also there's ICS, SCADA, especially for IoT and OT traffic and systems. We can identify a lot of those applications and protocols, and we can show those to you in a simple dashboard. And not only can we show them to you, but like I said, we can give you the freedom to identify what apps. Okay, hey, I don't want this Twitter traffic. I don't want this Facebook traffic. I don't want this Instagram traffic to go to my PCAP tool because it's wasting and it's taking up space. Well, now we can just allow you to select those individual applications and say, hey, I don't want this data going to that tool, right? So that's the filtering portion of it. And then lastly, we have our application metadata, which is also great for zero trust, because zero trust is all about establishing dynamic risk, making decisions based on additional context. If an employee is trying to access a high value resource from inside the data center using a company issued workstation, and they have the proper credentials, then that might give you a certain high score to give you entry. But say if that same user is trying to access that same high value asset from a city that they've never tried to access that resource from, and from maybe a personal device that's not familiar, then that extra context is really going to help make a decision on, hey, maybe we should raise a flag, maybe we should make them authenticate again, or add another layer of authentication, right? So a big part of actually playing that out is to provide more context. And the fact that we can do a deep packet inspection on each packet not only allows us to identify what applications are running in those packets, but we can now extract application specific metadata from those packets as well. So across the 3,000 applications, services, and protocols that we can, identify out of the box, we can extract over 7,000 metadata attributes. So a bunch of granular data points that you can send to a SIM tool or a SOAR tool or any tool that can really take in flow records with metadata to triage, to correlate, and to help inform policy decisions in terms of allow or deny. So just to recap with the visualization, I've kind of covered all of this, but I just want to reiterate, like with the pillar slides of the capabilities, they specifically called out network data, user data, device data, application data. Well, app intelligence is great because it helps you visualize all those different types and families of data, right? It shows you. Now, we're not a tool, we're not the end all be all, right? But we really help give you a deeper glance into what you're working with across your enterprise before you send to that tool for further processing or, what that tool was purchased to do. The filtering aspect of it is now that we see those different apps, we can determine what applications go to which tools, right? So we really help you manage your traffic, but also what's coming from a complete set, and you really know what that traffic is. And lastly, with the application metadata, as I mentioned, 7,000 metadata elements gives you a lot of room to work with in terms of what stories do you want to put together. Now, in these particular examples, we have like a NoSQL database and a SQL database, and here are a few of the different metadata attributes that we could, extract from those. But, even with encrypted traffic, like SSL traffic, we can extract over 30 different metadata attributes without even having to decrypt that traffic. So, certificate issuer, expiration date, cipher suite, some of that information can really, really help you out in terms of stitching together a really interesting story, even if you don't want to decrypt certain traffic. File sharing examples like Dropbox, Box, right? Like that user login, file upload, file download, especially as you're sending data or, some of your employees are using these different applications. It's important to know what data is being moved around and what's being utilized. And so the metadata attributes give you a lightweight way to get a lot of different data points to stitch together a more vivid story. And as I mentioned before, we even are able to extract metadata across different SCADA, ICS, OT, IoT applications that we can send to any type of SIM or SOAR tool to parse through. So if you stitch together even a few of the different protocols that we're able to collect, like DNS, DHCP, SSL, Telnet, SSH, right? You can, come up with interesting stories that, in this case, we have like pre-built applications on a few of the major SIEMs marketplaces that we can send these metadata records to in the form of either NetFlow, IPFix records, or CEF, which is CEF, Common Event Format. And they can parse through that data, and we'll have an app, a Gigamon app in those marketplaces, whether it's Splunk, Elk, QRadar, that'll display that metadata for you into interesting use cases. So data exfiltration, we can show you dashboards on meaningful data just off the metadata alone, not even just sending raw packets. So it really helps out in terms of consumption and volume ingested as well. Data exfiltration, suspicious remote connections, time windows, high privilege user activity. This is all zero trust, right? Wrapping more context around activities to really find out, hey, what should I really raise a flag on? Or, I should inspect this a little bit deeper. So I've mostly been talking about, just from a general hybrid perspective, but a lot of the solution capabilities are more so from an on-prem perspective in what I've presented. But we also work within virtualized environments with our V series. We have, for our hardware series, it's easy. It's our H series. For our virtual series, it's our V series, but they pretty much function exactly the same. If you have an environment such as VMware, Nutanix, or OpenStack, where it's on-prem and you own and have access to the hypervisors, we can deploy our V series directly on those hosts. And this is great for capturing east-west traffic across VMs that you have deployed on-prem. We can really capture that lateral movement, that east-west traffic, aggregate it, just like we've been talking about already throughout this entire presentation. Aggregate that data, make sense of that data, filter data before sending it out of the environment to whether you have physical tools. It really helps open up the amount of data that the tools that you've already purchased now have a wider amount of data that they have access to, or a larger set of data. They also now have access to the east-west traffic that you have in your virtualized environment, right? And say, you know, we're flexible with our V series. Not only do you have the capability to send that out of the virtualized environment, but you can also send that to virtual tools. So we really give you flexibility, not just in accessing data, getting that east-west traffic, tracking that lateral movement if an adversary is in that environment, and being able to send that to wherever destination, whatever your tools are and wherever those tools are. And, you know, I'm kind of breezing through these slides because Jorge is going to do a slightly deeper dive in a demo. And so, you know, I can't steal his thunder, but I'm not even going to try. So in a real life use case, we're actually deployed in a zero trust reference architecture project at the Dreamport facility, which is a collaborative facility for government agencies as well as private entities in Columbia, Maryland, pardon me. And so it was created by Cybercom through this partnership with Maryland Innovation and Security Institute a few years back. And the goal was to accelerate Cybercom's defensive and offensive capabilities. But other agencies such as DoD, Army, multiple different branches have come together to collaborate at this space for this project, and a number of other projects as well. But this project has been going on a little bit closer to 2 years now with Gigamon and one of our partners, ClearShark, is great at what they do. And the goal was to build a high DoD enclave zero trust working pilot. So a pilot that shows zero trust in a very highly classified DoD enclave scenario. Prior to Gigamon being involved, it was a standard architecture, right? And they were using spam ports to, you know, get some sense of visibility and then send mirror copies of packets to tools. And spam ports are great, but you often run into spam port contention where there's not enough spans on the switches and the ports to really send data. Spans aren't really that reliable when it comes to sending one-to-one copies of packets because they often become oversubscribed and they begin to drop packets, and you never want that. And also, you know, to create a spam port, you have to configure ports on the actual infrastructure itself. And we believe it's more efficient to, you know, leave the infrastructure to do what the infrastructure main purpose is to do, which is to move packets and frames, not to mirror traffic and send it to a tool for analysis. Right now, sometimes spam ports are great for inter-VLAN communication and traffic that doesn't really leave the switch. But all in all, you're not going to get high fidelity visibility into any data if you're using spam ports, and it's not scalable at all. So before Gigamon got involved with this program, they had a lot of blind spot steals because they were just using spam ports in only certain parts of the network. They were getting insufficient access to data. And with the insufficient access to data, it's really hard, regardless of what tools that you have, to monitor or really glean meaningful insights. In fact, there was a red team exercise that took place early in the project where they were able to access resources within the virtualized NSX environment within VMware without raising any flags for the tool. So you can tell that there was a visibility problem, and they were getting any visibility into any east-west traffic in the virtualized environment. Whatever visibility they could get from these environments was if data left the environment and hit the switch. But if it was all lateral, they weren't seeing anything. Lastly, because you're using spam ports, you're getting a lot of duplicates and you're not able to deduplicate them. And, you know, certain SIEM and SOAR tools or tools that are just based off volume ingestion, you're going to have to pay a price if you're taking in excessive data packets, especially if they're duplicates. You're kind of just leaving money on the table, right? So they desired a more scalable solution, right? But also a more efficient solution to access data, gain complete visibility, and send data to tools. And that's what we were able to provide, right? So these orange T's that you see are taps that we were able to deploy in the physical infrastructure to gain one-to-one fidelity, right? Because, you know, it's pretty much a bump on the wire. We were able to mirror one-to-one copies of traffic without disrupting the infrastructure. We did use some spans because, like I said, inter-VLAN traffic that doesn't leave the switch, that's what they desired. It works with us. We can take in that traffic as well. And also, we wanted to get that east-west traffic, so we deployed our virtual taps within the NSX environment. We were able to capture that east-west traffic, and we were able to send all that tap traffic, whether it was virtual or on-prem, to our physical HC3. This is one of our 8 series boxes, our big one, that was able to process all that data. And we were able to send independent custom data streams to each respective tool. So in this scenario, they wanted to see all traffic, right? They didn't want to remove certain protocols, right? Because they just wanted to inspect everything. However, they did want clean data. So we were able to deduplicate data in certain scenarios. We were able to slice headers for encapsulated payloads so they can open up analysis to certain tools. And then for some of the seams that they were using, we were able to deduplicate as well as extract metadata and only send the metadata logs. So it was a compound effect in terms of how I was able to save up in terms of ingestion and also expand the amount of meaningful data that that seam was able to process. So the next step in this project is to explore cloud visibility, so public cloud visibility, which we're able to provide, and Jorge will talk about in a minute as well as our inline decryption. As I mentioned before, if we are deployed inline in the physical infrastructure, we can decrypt live production traffic in a break and inspect way all the way up to TLS 1.3. Out of band, in this scenario where we're just taking tap feeds and spans, we can decrypt all the way up to TLS 1.2. Still extremely useful in being able to decrypt traffic and send more meaningful data to tools. And those tools don't have to decrypt and deduplicate and, you know, take away processing power from their main functions. So, you know, before I take a break and hand it over to Jorge, I just want to reiterate that when you look across not just our on-prem virtual cloud, but also we're able to, you know, but also our public cloud visibility options, it's the same solution, our V series. We can deploy it on-prem, and we can also deploy it in whatever VPC or, you know, virtual private cloud environment you have stood up, in regardless of what public cloud provider it is. Wherever your data is, we can provide a visibility node to access data and tap those compute instances or VM workloads. And with Fabric Manager, you don't have to, you know, ad hoc and in a siloed way kind of configure these different policies in these different environments. You can use Fabric Manager to drill in and out of each virtual environment, cloud environment, and on-prem environment to make changes on the fly. So it makes it super easy to manage. And with that, I will take it over and stop sharing and allow Jorge to show us a little bit more of how this all works.
Yep, thanks, Matt. Good morning or good afternoon. It's probably still good morning, everybody. My name is Jorge Valverde. I'm a SC or sales engineer for Gigamon. Primarily support the civilian accounts here on our side. I know that Matt mentioned that I was going to do a demo, which I will. I just have one little slide to show because it's definitely kind of basically sums up exactly what Matt's been talking about. At a very high level, Gigamon primarily is going to give you the flexibility, the ability to capture traffic on different types of infrastructure. So regardless of whether the information or the network data resides on specific applications that can't be cloud ready, maybe you have IoT appliances in your environment, maybe you have containers, maybe you have 5G mobility, maybe even voice SIP traffic. Gigamon will basically acquire this network traffic, whether that's in the cloud, on-prem virtual like VMware, Nutanix, or physical data centers. And what we do in the first part here is aggregate traffic into an appliance. And what I'll be talking about is kind of more of a hybrid model in the demo, kind of showcase that that really doesn't matter where your network data is. Gigamon can acquire that network data. And what we're doing is aggregating it first so we can optimize it and send it to your security appliances. And the optimization piece really is, I think, the first stage, the fundamental piece where we're reducing traffic going to your security appliances. And that's important because security appliances, as we all know, network data continues to increase. The networks are growing in size. There's going to be more traffic or more data going to the tools. So we want to make sure we're reducing what your tool doesn't need to see. And then, of course, optimizing it is the next phase where we're doing those additional features where we might do TLS decryption, might do net flow generation, might do deduplication, and then just basically making your security tool more efficient in that phase. So with that, that is the last slide I wanted to show you guys. And I'll go ahead and run into the presentation here. So what I have here in front of me is basically Fabric Manager, and Fabric Manager is that key feature or key appliance that we need to have in the environments, at least from the Gigamon perspective. And what I mean by that is, without Fabric Manager, we can't get a full picture or full visibility fabric deployed, meaning that you might have physical nodes in your environment capturing network data, from data centers or specific connections within your data center, and you could log into those individually and manage them and configure them. But then when it comes to, okay, well, now I've deployed cloud VMs. I've deployed, my users are now going into cloud servers that are providing them services. The question comes, well, how can I secure those, or how can I get visibility into those environments so that we can run security, our security tools to inspect that traffic? And that's where the key of having Fabric Manager comes in. Without Fabric Manager, we can't do those deployments, and this is pretty much what I'll be showcasing. So again, Fabric Manager is that single pane of glass where you can administer your entire visibility fabric. And what I mean by visibility fabric, it basically means all the components, whether it's physical Gigamons, as in my case, I have an HC1. This is a physical Gigamon in my environment. You can actually manage it, administer it, configure it, go in and do any specific capturing of ports, sending it to tools, pretty much administer anything on the Gigamon, physical Gigamon itself. When it comes to visibility in the cloud, you can actually deploy environments, Gigamon virtual appliances in the cloud. And as you can see here in this section, you can do this directly from Fabric Manager. You can say you have an AWS environment, you can actually integrate FM to communicate with your AWS account or multiple accounts, and then deploy the Fabric through Fabric Manager. So what we're doing here is we're basically allowing our customers to integrate their accounts or their AWS environment with Fabric Manager. So that way they don't have to log inside AWS and do a manual deployment. You pretty much have to just come in here, create a new session, and then enable, give basically Fabric Manager the ability to deploy these nodes so you can start to gain that visibility into these environments. The same concept applies for Azure. You can just go into the Azure section and do the same thing, connect it to your subscription within Azure, and go through the same process as far as deploying the nodes. And then same with containers and on-prem virtual environments like VMware. You can integrate Fabric Manager to communicate with Vcenter and deploy the vSeries node, which is that visibility appliance, that virtual visibility appliance to start to capture traffic. So I will kind of show you how this works. I already have it deployed, so I didn't want to go through that deployment phase. But basically, if we take a look at Azure as an example, if nothing existed here, a monitoring domain will basically give you that capability for Fabric Manager to communicate with the Azure, with your Azure subscription. So you would pretty much go into this deployment process here. Now, one key takeaway from doing this, specifically, we're talking about the big cloud environments like AWS and Azure. Gigamon does support other environments like GCP or Oracle, the integration with AWS and Azure, since they are kind of the market leaders in the cloud space, the integration is already enabled with Fabric Manager, meaning that you can enter your information for your account and then basically deploy the Fabric directly from Fabric Manager. With GCP, it's a little different. You have to use something called AnyCloud. AnyCloud basically is a support to, it's basically our way of supporting future cloud environments or future cloud vendors that might come up in the near future. So you could still deploy Gigamon inside other cloud environments, but the main support right now is AWS, Azure, GCP, Oracle, and of course on-prem Nutanix, OpenStack, and VMware. Now we take a look at this. There are a couple ways to capture traffic when you're doing the deployment. In Azure currently, there is two ways. There's basically you have to use an agent, a Gigamon agent. It's called Gvtap. You would install the Gvtap inside your VM, whether that's Windows or Linux, and then that Gvtap agent will communicate back with the vSeries node, and I'll kind of showcase what that might look like. But then the other method here is tunnel. The tunnel basically means that if you have like a load balancer within Azure or maybe an external device sending traffic, and you want to ingest that into a vSeries node, you would use tunnel as your traffic acquisition method. Currently, that's the only two options within Azure. They were deploying, or they were doing a mirroring service, but they kind of stopped that, I believe, last year sometime. And I believe it might be coming back and probably providing that to customers in the near future here. But right now, the only acquisition way as far as capturing traffic in Azure is Gvtap and Tunnel. On the other hand, with Azure, with AWS specifically, there are an additional method, and that's basically using something called VPC Mirroring. So with AWS, you could use the traditional agent-based solution, or you could use a tunnel acquisition, but you can now leverage also their VPC Mirroring. And there could be different use cases as to why you might want to use VPC Mirroring versus Gvtap. And I think the primary one is that with VPC Mirroring, you don't have to install the agent on appliances or VMs in AWS. So for example, if you were to deploy a virtual firewall, you probably can install an agent in that case on those appliances. So you would have to leverage VPC Mirroring in that case if you wanted to capture traffic maybe on incoming ports or egressing ports. So that would be kind of one reason why you might want to use VPC Mirroring. Now, VPC Mirroring in AWS only works on certain types of hypervisors or VMs, and they're termed Nitro-based. So that's the only caveat of using VPC Mirroring, and that's an AWS functionality, meaning that you have to have that type of VM running, that type of hypervisor to leverage VPC Mirroring. But that's pretty much the traffic acquisition on both fronts. For Vcenter, it's a little different. Vcenter, we would actually deploy a VM inside the ESXi host. So when you enable this connection to Vcenter, so when you create a monitoring domain, you would be asked and prompted for your Vcenter information, an admin username, password, and then we would basically connect to the Vcenter environment. And then at that point, you're going to be able to deploy a visibility node and push it out to Vcenter. So in this case, as an example, I have vSeries nodes deployed inside ESXi host that can now communicate back to Fabric Manager. And then when I create my maps and the rules of how I want to capture traffic and what VM I want to capture traffic from, vSeries is basically kind of that middleman doing all the heavy lifting in the back end within the vCenter environment. If I have time, I'll kind of show you what that looks like. But let's jump back to cloud. And Matt, let me know if there's any questions popping up because I don't have the chat in front of me. And just shoot comment. Okay, perfect. So when you actually implement this deployment, again, you're doing the deployment directly from Fabric Manager. All the VMs, all the actual instances already reside inside AWS. There's AMIs already built inside the AWS environment. So you basically, when you're enabling this this monitoring domain, you're basically allowing your account to be tied to that subscription. And at that point, your account now has the access to those AMIs. And what I mean by those AMIs are pretty much those images, the vSeries images or the vSeries controllers that we'll need to deploy to make this work. So once you create your monitoring domain, that connection to your AWS account, you're now ready to basically launch your Fabric, your vSeries node. Sorry, I was in the wrong section there. So within the Fabric, you're going to get prompted for specific information. And usually what that is your VPC that you want to deploy the vSeries node into. Usually there might be, I guess, best practice is you want to separate your security, I guess, VPC from everything else. So you might have a specific VPC for the security inspection or security tools. So let's imagine that's the case for my environment where I deploy vSeries into a security VPC. And then this VPC has peering access to other VPCs within my environment or within my account. Once you go through this deployment, you'll be asked for, like, if you want this to be a private-based vSeries node, or maybe it's public-facing. In my case, I'm using FM in a local lab here, so I need to have a public-facing IP on my vSeries node so I can communicate with it. So FM can manage it pretty much. And then once you go through this part, you pretty much hit deploy or save, and then the instance actually gets deployed inside your account or that VPC. Nothing really happens. You don't have to do anything from here when this happens. Everything, again, is done through here. Once the vSeries node is deployed, you'll pretty much get an OK status. It's ready to go. It's ready to consume traffic. And then the next phase would be going into your into your something called a traffic acquisition for virtual flows. So in Fabric Manager, and again, note the fact that I'm still in Fabric Manager. I haven't logged into any other window, and that's pretty much why we want to use Fabric Manager, because everything's done from here. So from Fabric Manager, you would log into the orchestrated flow section and figure out, okay, well, let's say I have a Azure environment. I did the same thing. I created a monitoring domain, and now I'm ready to capture traffic. So once you're ready to capture traffic, you would basically create a monitoring session. And that's as easy as just going in here, giving it a name, and then selecting what actual monitoring domain that you created. So if you create an AWS one, you would select that, or an Azure one, and so forth. So from here, you would select the VPCs, or in this case, VNets for Azure, and then you would hit create. When you do this, then you're going to go into something called a canvas. Now, this is the same for across the board. And this is kind of, I think, a good point to bring up. Before our new vSeries 2 or Cloud Suite upgrade, basically, there was or original vSeries 1 of way of capturing traffic on in a virtual environment. We had to deploy different types of different ways of capturing traffic, meaning that if you wanted to do it in the cloud, it would look like this to capture traffic. If you want to do it in VMware, it would look completely different. It would look like this. So you had to relearn or learn a new way of capturing traffic in that type of environment. So what we did with vSeries 2 and the new Cloud Suite is we made it all the same. So if you go into AWS and you want to capture traffic in a monitoring session, you would see the same thing. If you wanted to go into VMware, you would basically go into your monitoring session, and you would basically see the same thing. There's no difference as far as what you'll see. It's pretty much the same thing, the same type of canvas. There might be a few differences as far as applications you could use based on the licensing, but everything is pretty much in the same place. So if we go back to our Azure monitoring domain, and we go back in the capturing of traffic, this is just a kind of simple example of how to capture traffic. I'll kind of show you what you'll see on one side here. So this side is kind of like your informational section. It'll give you what you created for this monitoring session, so you'll know what monitoring domain you're in and what VNets you can support or capture traffic from. And since I'm in my Azure monitoring session, the only acquisition method I used was Gvtap. So what you'll notice is orange coloring means that you have a Gvtap agent installed on here, and it's communicating back with vSeries. And this is a potential target to capture traffic. Anything that is grayed out pretty much is not a potential target. Either you filtered it out or it doesn't have an agent installed. And that's the case for this. From here, you can select different VNets, and that's the terminology for the Azure environments. For, I guess, VNet equals VPC. And you can pretty much move around and select the other VNet that you want. And you can capture traffic from maybe a host. Maybe you have a VNet that just has hosts or VMs that you want to capture traffic from. So that's what this showcase as far as targets. It's telling you what's available that you can consume. If you go into the list view, it will actually tell you more information about these VMs that are potential targets. It'll actually give you the IP information from these and what subscriptions they're tied to, MAC addresses that are, I think, pretty much important, because that's how you might be capturing traffic. You might create a filter here, which I'll show you in a sec, based on specific information like this. Now, you can kind of look through here and see exactly what you want to consume, and then note it. And then when you're ready to create your map, you're basically now creating something equivalent to a flow map, but in the cloud or on a virtual appliance. So a map is equivalent to creating flow maps within the physical Gigamon appliance. What we're doing with a map is we're going to filter traffic out. And you can do this with pretty much criteria ranging to IPs, port numbers, MAC addresses. And now in the cloud, it's more relevant. Tags are relevant, and then also names of VMs. You can pretty much filter based on specific information like this. So this is stage one. If we go back to the filtering, you're basically doing this right here. You're able to aggregate from multiple VMs based on, let's say, my lab environment here. You're able to capture traffic from any potential target, and then aggregate it all that traffic based on specific filters that you have. And then vSeries now is consuming this traffic. And what happens in the backend is actually a Gvtap agent that's running. And let me see if I could show you that really quick. So I have a Linux box in here where it will show me basically, I have a Gvtap agent installed and listening to vSeries, the vSeries node. So the vSeries node basically is going to be talking with the Gvtap agent. And as you can basically see, it's going to give you a bunch of client requests, monitoring sessions, and basically create a VXLAN tunnel to the vSeries node. So what happens, I guess, to kind of explain what's happening here while I'm doing this, when I hit deploy, when you create a filter, you're basically saying which VM or which specific information do you want me to consume from. So in my case, my filter is pretty simple. I just want to filter out one VM, this 1.4, which is this guy right here. So when I do this, it basically will say, okay, just give me information or capture traffic based on that Gvtap that's installed. Initiate a connection with the Gvtap agent. So the vSeries is going to talk to this Gvtap agent that's installed here and create a VXLAN tunnel and send me captures of traffic from the interface, the production interface, and send it back to me. And there's multiple ways you can actually configure the agent to capture traffic. You can capture traffic using the same interface. You can capture traffic using a separate interface and send it out a completely separate interface, the tunnel that's going to be sent, I guess the traffic that's going to be sent out of the Gvtap, it can go through a separate tunnel or separate interface. So there's different options that you can utilize for how you want to send the traffic to the vSeries node. But basically what you're doing with this is you're saying capture traffic from this device, send it to my vSeries node, which is what I'm in right now. This canvas is basically the vSeries node. And now vSeries has this traffic once this map gets deployed. So the next step is really, it's really kind of the use case that customers might have. So for example, you might have multiple IPs, you might have another condition in here, you might create another map where you need to add another device and capture traffic from another VM and so forth. So it really depends on what you're trying to do. But basically, once vSeries has the traffic coming into it, then you could do those additional GigaSmart optimization features. So you could initially dedupe the traffic as it's coming in from this map and send it to a dedupe engine that resides within the vSeries node. And what that will do is basically remove any duplicate packets that you might be getting. Additionally, you could say, well, I'm only interested in a certain set of packets within the payload. So you could slice the traffic and offset at a specific number. So you could run that type of feature if that was a use case for you. I think the one that's really, beneficial for a lot of customers is something called load balancing. The load balancing feature allows you to receive the traffic and basically send it to multiple tools. So if you had another tool, let's say that this is a cloud-based tool, you can actually send it you could send this directly to, let's say, one session goes to Azure NTOP, another one goes to another Azure NTOP image. So you're basically load balancing between tools. So that's another feature that you can kind of take advantage of. I think that one that's really important to note is traffic coming into the vSeries node. So I guess another use case for this would be if let's say you had an on-prem switch that you wanted to span traffic out of and send it to vSeries because you had a cloud-based tool that was receiving traffic from vSeries. You can actually drop a tunnel configuration in here and call it span local or something from basically your local network, your data center, and then you would be able to consume this traffic inbound. So you could basically ingest traffic coming in to the vSeries node and receive traffic from remote devices. That is definitely a use case you could do now with vSeries 2. So once you do this, you could pretty much deploy, and all this configuration would be pushed out to vSeries, and then your tools would be receiving traffic in that case at that point. So what I'll do is I'll kind of take a little pause here because I know I kind of went over a lot of stuff. And I don't know if there's any specific questions before I move on to what this looks like in VMware, because in VMware, there is a little bit of a difference as far as another capability you can take advantage of, which is kind of something Matt talked about with App Intel.
So far, so good. You can keep going.
Okay. So if we go to VMware, again, the concept's the same. You create a monitoring domain. The monitoring domain is basically the connection to vCenter, and then you would push out the vSeries node to capture traffic within that environment. So when you're capturing traffic here, the concept's the same. If you go to VMware and you go into your environment here, and you edit this monitoring session, you basically will see the VMs within that ESXi host. So what you could do from here is pretty much the same thing. You could filter traffic out from any of these VMs. You could ingress traffic from a remote tunnel. You could dedupe, you could load balance, you could send it to tools. So as far as what you could do on the canvas from a VMware side, it's pretty much the same. The only difference right now, and this works in AWS as well as VMware right now, it doesn't work in Azure. It's not supported in Azure yet. It will be in the probably next release coming up. But basically, you can now deploy App Intel inside your vSeries node, your virtual appliance. So now you can take advantage of the application filtering. You can take advantage of the application metadata generation to send to a SIM in this case. So the way this works is you would create virtual environments inside Fabric Manager, and then establish a connection to your hypervisor. And let's say for VMware specifically, you would establish a connection. And in essence, what you're really doing is you're just creating a monitoring domain. You just have to do it a little different for this to work. But basically, you're establishing a monitoring domain. So now the vSeries node gets pushed out to the ESXi host, as you can kind of see here. I've already done that. And now you can actually use application intelligence instead of the maps to filter traffic out and send it. Now, what the benefit of this is the fact that the vSeries node is going to do deep packet inspection on traffic coming in from whatever specific VM of interest that you're asking to capture traffic from. So as an example, when I created this, I used my source traffic as this file server, which is residing within one of these ESXi hosts. So this file server right here is residing in most likely HV2, and I have a vSeries node within HV2, so I can capture traffic. And so when you're doing this, you're actually doing two things. The first is it's automatically creating a map for you. It's automatically going to create a monitoring session for you. So if we go back into monitoring session for VMware, you'll notice that some of these already have these weird names on it. It's FM Auto. That's basically because Fabric Manager automatically created this monitoring session for you and capture traffic from that specific VM. So you didn't have to actually go into the canvas and manually create a map based on what you want to capture. It was done automatically for you based on application intelligence. So that is one newer feature that is out and available right now with vSeries. So this basically does the automatic of capturing traffic. It'll create the monitoring session for you. It'll start to capture traffic, and you could send it to a tool. So you could send it to whatever tool you want. So once it's capturing traffic, you can actually send this to the specific tool of interest. You can even filter it based on traffic. So you could say, I'm only interested in passing specific applications to my specific tool. That's, I think, really important to kind of talk about a little bit, because with flow mapping or with the canvas and the mapping that we were showing you a little bit earlier, you need to know the IPs, you need to know the MAC addresses, the names, the VLANs. You just need to know more about what you want to do. But you might not know that the application of interest is running on a standard port. Maybe there's DNS traffic that is running on a non-standard port, which I think is relevant because that could be a vulnerability within an environment. Someone is using DNS over a non-standard port and so forth. So Gigamon's App Intel will recognize the application. It doesn't care about the IP or the port number. It will just recognize that based on signatures, it's actually DNS traffic. And so what you could do is you can actually click on the specific application of interest and then filter that and send that to a specific tool of interest. So that's the first part. You're basically filtering on application versus filtering on port or IP. And you don't have to worry about creating the map. It will be done for you automatically because you're using App Intel. So the next part I think that is important with this is the fact that you can leverage App Intel in cloud now, in AWS specifically right now, and VMware. And now you can actually run application metadata. So application metadata is basically going to allow you to send traffic to a SIM. Splunk in this case, let's say, as a use case. So let me see if I have one configured in here. I think I did. Maybe not that one. Not, I'll just walk through this. Yeah, here we go. I think this one's working. So the concept of this is basically you have the capability of looking at traffic that's residing within VMs that you're interested in capturing traffic from. So you're able to do DPI on that specific captured packets, recognize applications, and do filtering that way. But now you could take advantage of the metadata piece and say, well, I don't want to just capture traffic. Now I want to send relevant metadata, enriched metadata to my SIM. So when Matt was talking about enriched metadata, he was referring to the fact that Gigamon app metadata can basically generate metadata for a lot of different attributes within a lot of applications, as you can see. This is just a template. So we've already have a template for Gigamon. It's called App Intel for Splunk. And when you install that, we already have a predefined template that we've created for our customers. So you don't have to build one right off the bat. You can actually just use this template and get a lot of good information from a lot of applications, known applications that might be applications of interest that maybe bad actors could be using to do malicious things on a network. So, but you can see just by expanding some of these applications, there's a lot of attributes that you can generate metadata for. Now, this all comes in a Ceph format, and Splunk works with that. There are other SIMs out there like QRadar, Bro, that you can leverage, but that doesn't mean that any other SIM won't work. That means that there might be a little bit of legwork on the SIM side to make this work, but Gigamon will be able to generate a Ceph format type of metadata and send it to a specific SIM. And you can choose pretty much any attribute from any specific application of interest. Now, the other thing to note here is that you can actually, let me see if I can create another one here. You can actually create, I believe, up to 5 exporters from here. So you can add another one. So let's say that you're generating metadata for Splunk. Maybe you have another SIM that needs it. Maybe it's a cloud-based SIM or QRadar or anything like that. Well, you could actually, and let's say that SIM doesn't like Ceph, maybe it likes NetFlow. So you can actually create another exporter here and change it to NetFlow. So now you're generating maybe IPFix information or basic NetFlow information, and you can actually now send that information also to another SIM. So you can send Ceph format, you can send NetFlow, IPFix, you could send it to multiple SIMs. And it's basically for pretty much the same set of traffic that this virtual appliance is capturing. So again, if we take this step back here to kind of go over this a little bit more as far as flow of traffic, App Intel is the GigaSmart feature that's running within the virtual appliance that you deployed inside your VMware environment or cloud AWS environment. And because now we're integrated with Vcenter, we're integrated with AWS, you will have access to the different VMs as far as capturing traffic. Now with AWS, you have to figure out if you're going to use AWS Mirroring or Gvtaps. But with VMware, it's easier, I think, because it doesn't matter. You don't need to install agents. It'll leverage the port mirroring function within the vCenter environment or vSphere environment. And so when you select a source, you're in essence basically saying to vSphere, hey, initiate a port capture session from this VM that resides within that ESXi host and send it to maybe a tool But then I want, because I'm capturing that traffic, now I want to send it metadata to a SIM. So you can do this all from a virtual appliance. Now, this also works with physical appliances. So you can do the same thing. You create another session and run it on your physical appliance. So you can create another app intel session and pick your, let's say your HC1 in this case, and create a new monitoring session. I'm sorry, a new app intel session for the physical node. So we've taken basically what we do on-prem and we're basically taking it to the cloud. And the whole purpose of this is because everything is becoming hybrid at this point, and most likely will continue to be like that in going into the future. I don't think that that's going to change. So we, Gigamon, want to give our customers the capability of capturing traffic and running and optimizing and aggregating and making their tools run more efficiently, regardless of where that data resides, whether it's in the cloud, on-prem, virtual, or physical, doesn't matter. We want to send it, we can capture it, we can aggregate it, we can optimize, and we can basically send it to either tools that are on-prem or even tools that are cloud-based. So other than that, that's pretty much kind of what I wanted to showcase, Matt.
Jorge, this was awesome. Thank you so much. I really appreciate it, man.
Yeah.
Cool. I'm going to share my screen after you stop, and I'll finish out with some scenario slides. We have less than 10 minutes left. And, you know, Jorge's pretty much covered the gamut. So this will kind of just be a quick recap in regards to the different 12 scenarios that ATARC has brought up in terms of, you know, how would our solutions address these scenarios. So I just want to just reiterate that in terms of establishing a dynamic risk evaluation, we can do that with our metadata generation, our net flow generation, right? Getting all that enriched metadata, that contextual aware information to send to your SIEM or SOAR tool to do the correlation, if that's your policy decision-making point, right? Is we can send it as much context as needed, over 7,000 different data points or attributes. And you probably don't need all 7,000, but it's better to have it and not need it than need it and not have it, right? So, you know, we were really robust in terms of the layer 7 awareness in terms of getting those particular attributes that could be pivotal in making an allow or deny decision within the zero trust architecture that you deploy, right? And Jorge has already kind of covered this, but it's a bunch of different protocols and attributes and applications that we're able to extract metadata from. These are just kind of the counts for some of the popular ones. Scenario 1 that was brought up was you have remote users trying to access cloud resources. So in this case, as Jorge has demonstrated, you know, if that user, regardless of where that user is, if they're accessing workloads, EC2 instances, GCE instances, whatever, you know, Azure instances, we're able to, you know, tap those workloads and aggregate all the traffic. So any activity going on in that cloud, we're able to access it and send that to whatever tools that you need, whether they're in the cloud or even on-prem for analysis. Satellite offices are very similar, right? If you have a small office, we're able to tap where you can, span where you must. We can tap virtual nodes that they have deployed, VMware, as Jorge has demonstrated. We can get full visibility into those remote locations. Even if we're just not using physical nodes, we can use our vSeries nodes to still give you some sense of visibility into those smaller offices. Once again, with the goal of being able to send relevant traffic to whatever tools you have deployed that you need to analyze them. All right, and it's more of the same. If you have a development network, a production network, and you know you have control over all that, we prefer that you tap everything, give visibility everywhere. If you have a one tool suite, you can use one tool stack to monitor both networks. It really helps save costs, right? And you can still isolate that traffic, right? Even if you have a completely cloud native solution, we're able to tap those workloads. So wherever you are, and wherever your workloads are, or wherever your tools are deployed, we're able to access that data or send data to that tool. If there are separate agencies that are exchanging high value sensitive data, if we're working with both agencies independently, we would deploy our visibility fabric into their infrastructures in the cloud. Right now, in terms of sharing data, that might be a decision that's up to them. However, if they wanted to do so from a physical perspective, in terms of sharing data from one environment to the next, they could use our solution to do so as well. First, like in the cloud, if it was both both scenarios, we're in the cloud, we can tap that information and send that data to that tool, right? On-prem, we can tap all those different data paths where data is in transit. So we're capturing that, aggregating it, making sense of it, filtering out the noise and sending that to the tools. But also, we're able to use our taps not only to copy one-to-one packets, but we can also use those as cross-domain solutions. So sending data from maybe a low side environment to a high side environment. In this case, we're actually used in the Air Force, specifically called out in their Defense Cyber Operations Reference Architecture, and how our taps are used to send data one way. So in a unidirectional way, and there's no way that that data can be sent back. So we're enforcing the Bell-LaPadula model when it comes to confidentiality and being able to egress traffic one way without it coming back. So technically in that scenario, if it was a physical infrastructure between two separate entities, we could send data that's been filtered and pretty much optimized to another endpoint company and without any type of concern about interference in the opposite direction. So if you have any questions on that, feel free to reach out to me afterwards. And also we'll be very active in the ATARC lab after this week. So I don't want to take up too much time, but if you want to explore more of how we do this, please let me know. And then lastly, with the rest of the scenarios, I think you all get the gist, right? We can tap everywhere. We can get wherever that data is, wherever those tools are. We can access that data and we can send data to those tools, right? Cool. Lastly, as Jorge and I have, stated, we have a vast array of different ecosystem partners that we have official joint solutions briefs and collaborative marketing materials. But at the end of the day, we're tool agnostic. So any system tool that can take in data in the form of packets or flow data, whether that's NetFlow, IPFix, or Ceph, common event format, and we're always expanding those different formats as well. We can integrate, we can send data to those tools. So, you talk about the defense in depth and you talk about best of breed technologies and being able to switch and swap with what works best for you. Gigamon is really helpful in being able to enable that swiftness and that scalability and that flexibility. With that being said, thank you. We really appreciate you all for joining the call. Here's my information. If you want to talk to Jorge, you got to go through me. But yeah, I'll be at the lab. I'll be working with the ATARC team for the remainder of this project. And once again, very grateful for you all spending time on your Fridays to hear us talk about Gigamon. With that being said, thank you. Kirsten, is there anything else that is required of us?
No, thank you guys so much. This was great. And as a reminder to everyone online, all of the recordings, past and future, are or will be posted to our YouTube channel. So just look up ATARC on YouTube and you'll find a playlist for the Zero Trust Lab recordings. So feel free to share them out to anyone who may have missed this demonstration. But thanks again, and I hope everyone has a great weekend.
Thank you. Everyone take care.
Have a good
Bye.
one. Bye.